review today for the quiz. So I'm just going to start here, and I'm literally just going to type this lovely polynomial into my Desmos. And so I'm just going to write y equals x. And then, do you guys know how to make an exponent? You just shift and the 6, this little caret button. Shift 6 is how you get that. So x to the third, and then I just use the arrow key to go over. And then plus 4x squared. Shift 6 is how you get that exponent, and then minus 5x. All right. And then we all have these lovely touch screens, so you can kind of manipulate that so you can see the polynomial a little bit better. But the really nice part of Desmos is you can just click right on the point. It'll hold it for you. And I'm just going to click on these. I call it snapping a point. I don't know if that's the correct terminology, but whatever. So if you just click on it, it will literally hold it on the screen for you. So the relative maximum or minimum, they're going to occur at a turning point. If it's an odd degree, which that's what this guy is, you don't have an absolute max or min. You only have a relative max or min. So the relative maximum, don't have an absolute because it goes to infinity, don't have an absolute minimum because it goes to negative infinity, but we do have these relative max and min. So my relative maximum here, I just need to write the y value. And so for this graph, I just write like maybe, tell you what, I'm just going to write 24 point, I'll just do 2 decimal places, okay? You can do all 3 if you want to. And then the relative minimum is just the y coordinate where we've got little minimum values. So this point here, so about negative 1.38-ish, something like that. So just kind of rounding it. Most of the time these are not nice numbers when you do that. But that's all you have to do. It's just graph it in Desmos and it'll be really quick to find. Okay, if you want to clear it, I'm just going to hit the little X there. And, yeah.
It says to find the zeros, too.
Oh, fail at life. Oh. Oh my gosh, I can't type. So, no, I didn't do that last period, so fired. Okay. The zeros, this is nice as well. So you can literally just click on them. If it says find the zeros, I have, looks like -5, 0, and 1. So you can just see them, and you can, again, if you click on it, it'll hold it on the screen for you, and you can see those. So these guys are my zeros. All right. Now I'm going to drag this over so you guys can see the other function here. And then we'll just do the same thing. So it's not too bad. It's a little bit more work on the graphing calculator, I'm not going to lie to you. So that's why we're going to use Desmos to make it a little easier on ourselves. Now this starts with -x cubed, and then I've got plus 16x squared minus 76x, and then plus 96. And then again, you guys, it's really easy, especially with the touch screen. You can just kind of, if I try to move it, I try to grab like the x-axis and scrunch it in, or the y-axis, I just did that backwards, y-axis, x-axis, and you can just kind of move it, or like I could just pull it left and right if I don't want to change the scale. But here, if I want my relative max and min, those just occur at those turning points where it switches from increasing to decreasing. So on this one, my relative minimum, I can see that one first, about like -16.9. And my relative maximum there is about 5.05. I'm just doing 2 decimal places. Then your zeros, you just got to click the graph where it touches or crosses the x-axis. So my zeros there look like 2, 6, and 8. So this program, I love this, and it's free. You don't have to pay for it or anything. You don't have to sign in. You don't have to log in, nothing. It's just completely free. But this is really nice to just get a quick look at a graph if you need that. Is anybody having a question or trouble getting to the Desmos or anything like that? Yeah. Yeah, you can use the quiz on Desmos on the quiz tomorrow. Yes, yes, yes. Okay. Now, let me move this for a second. So I have a couple word problems, and you're like, yes, favorite thing to do in math. All right, now, I'm gonna have you do me one favor on this second example. It says certain airline has the following carry-on luggage requirements. Length of the carry-on must be 10 inches longer than the width. The sum of the length, width, and height, just pretend this says must be 40 inches. Don't worry, we're not gonna graph a less than here, just must be 40 inches. What is the maximum possible volume? Okay, this is kind of weird, but to do volume, we're gonna assume our carry-on is like a rectangular prism. So volume is length times width times height in 3 dimensions. Okay, now it gives me a little bit of information, and this is kind of a weird way to go about this, but it says the length is 10 inches longer than the width. So I'm just gonna say the length is the width plus 10. So I'm just gonna put a W there for that. Okay, now it also says the sum of the length, width, and height, and then pretend that just said must be equal to 40. So I'm gonna say length plus width plus height has to be 40. That's the only information that I have there. Okay, what I want to try to do is I want to try to give us an equation. It's totally fine to have the volume here, but I only want one variable on this side of the equation when I set this up. So to do that, I'm just going to use a tiny bit of substitution. So I'm going to say I can just call the width W, and I've got the length in terms of the width right here. What I don't have is the height. So what I'm going to do real quick, I'm just going to solve this equation here for the height. That's the only one that involved the height. To do that, I would just subtract the length and subtract the width. So I'm just going to write 40 minus the length minus the width. Okay, now I don't want to plug that in for the height because that gives me 2 different variables, right? But I can actually simplify this even further by taking what the length equals and putting that in for the length. So I'm just going to simplify this further. I'm just trying to take it down so it's only one variable. So instead of 40 minus the length, 40 minus the length is the width plus 10. So I'm going to sub that in. Okay, if we do that, we get 40, little distributive property here, minus W minus 10 minus another W. And then after all that work, if I combine my like terms here, I have, let's see, 40 minus 10 would be 30, and then I have 2 negative W's, so it would be minus 2W. All right, now, I know this is a lot of work, but once you have this, we're just going to put this in Desmos, and I will show you this is awesome. We don't have to multiply it out or anything. So I'm going to take, and I'm going to put this expression in place of the length, and I'm going to put this expression in place of the height, and then we will only have volume related to the width of the carry-on here. So instead of length, I'm just going to write W plus 10. Now width, we go ahead and just leave that as W, and then the height, I'm going to put that in as 30 minus 2W. Okay, now we don't have to FOIL this out or anything. All right, this is beautiful. I'm just going to literally grab my Desmos again, maybe. And I'm going to scooch this to the side a tiny bit. You can just type this in right with the parentheses. You don't have to multiply it out. The only thing you do have to do, you got to just change the variables to X and Y really quick. So just instead of volume, I'm just going to write Y equals. And then instead of width for W, just use an X. It's just not programmed to use other variables in this format. So I'm literally just X plus 10 in parentheses, another X, and then 30 minus 2x. You can just use the parentheses. You don't have to multiply it out. And then I'm going to maybe grab this a little bit here. And okay, guys, I'm going to pull this over so I have... Fail. No, what did I just do? Oh, I broke it. Okay, didn't really break it. I'm handicapped with computers. I'm sorry. Bless you. Okay. Now, I'm just kind of manipulating this so I can see the graph a little bit better. All right, and then I'm trying to maximize the volume. So you're looking for the relative maximum here. I would not even look at the relative minimum. We don't want to minimize how much we can take in our carry-on. That would be dumb. We want to maximize that. So I just want this point right here. And I'm going to write that down on my paper just really quick. I'm going to write down the point I've got like 8.93-ish. I'm just gonna go 2 decimal places, and 2052.21. If you're having trouble manipulating it, I will come look at it. It's sometimes annoying to work with. All right, so I wrote down those 2 points. Now here's the deal. The width would actually be what I had for my x coordinate. So that would be the width. If the question said like find me the dimensions, you could just plug 8.93 in for the width here, here for the height, and here for the length, and those would give you those 2 dimensions. The question doesn't ask you that. It says what is the maximum possible volume? That is just the y coordinate of that point. So the width we would want to use would be about 8.93 inches. The volume would be 2052.21 inches cubed. And again, if it asks you for the dimensions, you can just plug in what you got for the width to these expressions we had. This is the width. The length would be, what, 18.93, and the height would be what we would get when we plug it in there. Is anybody having a question? It's not bad to do once you set it up. Yeah.
I don't know what's wrong with this, but on business, it's giving me 2,
Ooh, I'll have to come look at it.
it's giving me 2 vertical lines.
Oh, not cool. All right, you guys look at this next example real quick while I go look at his graph. Yeah, if you guys need help, and sometimes it's a little tricky on the touch screen. Okay, very similar problem. It says design of a digital camera maximizes, so I'm going to look for a relative maximum here, the volume, while keeping the sum of the dimensions at 6. All right, so I'm going to say the sum of my dimensions, length plus width plus height, is going to be 6. It says the length must be 1.5 times the height. So I'm just going to put 1.5 times the height. And again, if we're maximizing volume, volume is length times width times height. So this guy's a little bit similar to the one we just did actually, although the variable, let's see, looks like my length is in terms of my height. So I actually want to get the height alone here is what I would recommend. So let me take this equation, length plus width plus height is 6. Let me solve that for the width, and then we'll have all our expressions in terms of the height, or in terms of the width, sorry. Yeah, no, in terms of the height is what I meant. Subtract length and height there. Your width would be 6 minus the length minus the height. But I know that the length is supposed to be 1.5 times the height, so I can just substitute that in there just to get rid of one more variable. So this would be 6 minus 1.5 times the height minus another 1 height. So this would be 6 minus 2.5 of the height. All right, now everything I can write in terms of the height there. So I'm just gonna sub this in for my width, and I'm gonna sub this in for my length, and we're gonna maximize the volume. So volume length is 1.5 times the height. The width was that 6 minus 2.5 times the height. And then the height, I'll just keep h. This is going to create a polynomial. It'd be to the 3rd power if we multiplied it out, but I'm definitely not asking you to multiply that out. We're just going to use our lovely Desmos to graph this for us. So let me see if I can pull this to the side. Maybe. Here we go. All right, so you just have to replace the height and the volume with y and x. That's the only thing that's different. You can just use the parentheses. You don't have to FOIL it out or anything. So I'm going to do 1.5x, and then I have 6 minus 2.5x, and then another x. You got make sure all the variables are the same. It won't do it if you don't do that. So just type that in there. Okay, now let me stretch this out a little bit so you can see it better. And again, you might have to just mess around with it for a second, but I'm looking for a relative maximum if I want to maximize my volume here. So it'll snap right to the point, right on the graph there so you can see it. So I got 1.6 and 7.68. Now, the way this is set up, the height would be the 1.6 and the actual volume would be that 7.68. This looks like it's in inches cubed. So my maximum volume would be the 7.68. If they asked you to find the other dimensions, all you would have to do is plug this 1.6 in here and here to get your length here, your width here. It just asks you for the or no, it does say what should each dimension be. I can't even read my own directions. Okay, so height 1.6 inches. Grab my calculator here because I'm lazy. All right, my length would be 1.5 times 1.6. I totally just did that on my calculator. Don't judge me. I don't like decimals. And I didn't say that out loud. Oh, no, I'm recording this. Great. 6 minus 2.5 times 1.6. And, oh, this is a nice number. The width would actually just be 2 inches. And you could check those real quick. If you multiply those three together, that should give you that 7.68 as your volume. Is anybody having a question about the Desmos or how I was setting up any of these equations at all?